it started. Okay, so let's take a look at these. And if we need to, we could do one of them. I mean, we could do more than one. And I was hoping that, yeah, it's optional. Why did I say optional? I don't remember. Maybe it was doing the Shapley-Shubik. Yeah, I don't have the whole thing. But did you have any trouble coming up with Shapley-Shubik power index? Can you do that? It makes sense. Doing the permutations instead of and then finding pivotal voters. Not too bad. Do we need to do one of these? So the Security Council, I mean, we could do that one for fun, since it says optional. Maybe you didn't do it, maybe you did. But what I would do is I would think in terms of this. We have 5 A's and 10 B's. The A's are the permanent members. The B's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The B's are the non-permanent members. And so then we have to think in terms of the number of permutations. So there are 15 factorial, wait, is that right? Yeah, 15 factorial permutations. But since these are all sort of similar, you have 15 factorial over 5 factorial times 10 factorial. And essentially, we just want to know of those, and there's a lot of them. I forget what the number was, it 3,000 something? Yeah, so some ridiculous number. But of those, basically, you're just sorting them by A's and B's in terms of being pivotal. So in which cases is a B pivotal and in which cases is an A pivotal? So let's just list off, like if this is the permutation, then you're basically the B is a pivotal, right? B is pivotal. So A will be pivotal, or the final A will be pivotal as long as 4, wait, is it 4 of the B's? We need 9 votes to win, including all of the A's. Yeah, so as long as 4 of the B's come before an A, or the final A. So let's see. So essentially what we want to know is how many permutations will there be? Here we go. We have 4 A's, 4 B's. So these people vote before the final A. So then the final A will be pivotal. So you have some permutation of this, and then you have the final A, and then we don't care about the B's. They can come whenever, they don't matter. So let's see, how many permutations do you have of this? So the number of permutations will be 8 factorial over 4 factorial times 4 factorial. That's the number of permutations. Whoa, what just happened? Can I go back? There. I don't know what just happened there. So that's the number of permutations of that. And then this A will be pivotal if that happens. But we have to worry about, what happens if you have 5 B's before the A and 6 B's and so on. So you can see that this is going to be a little bit challenging, but not terribly so. There's going to be, I think, I don't know, 6 or so different things I'm going to have to compute. So the next thing that you'd have to compute is how many ways could this happen? So 5 B's. And then the final A. And then we don't care about the other B's, of course, because this is the pivotal voter in this case. And so the number of ways this could happen, whoops, there are 9, and 9 factorial, 4 factorial, 5 factorial. So you can kind of see a pattern here. And the final answer for the number of ways that any A could be pivotal is the sum where, let's see, let's go from 8 to, let's see, 9. What's the last one? There's 15 of these people. So 14, I guess. It goes from 8 to 14 of n factorial over 4 factorial times n minus 4 factorial. Is that what this is going to be? So that'll be to have any of the, pick just that there would be an A to be pivotal in that many of the permutations. And then the rest of them, of course, and a B will be pivotal. So you might wonder, how could that be? Well, as long as you have the final A will be before the fourth B. So if you have some permutation of 4 A's and 3 B's, or 5 A's and 3 B's, then the first of the B's after that will be pivotal. So anyway, I'm just sort of pointing out that you could do this. It's not that hard, as long as you don't mind dealing with large numbers. So we would add these up. That's the number of ways, and A would be pivotal, and then subtract that from this to figure out the number of ways a B could be pivotal. And then, of course, divide by the number of A's, divide by the number of B's, and you'll get the actual number of pivotal votes for each of the categories. So, yeah, without actually doing it, that's how you would do it. You could do it. So, anything else you can do Shapley-Shubik for these other ones? Not too bad. Okay, well, if you're okay with that, let's move on. So I had a couple of things that I wanted to do today, and then just mention what's going to happen next week. So the first thing is this question that is the title of your textbook, or the book that I had you buy, is democracy fair? And I don't know what your opinion is about this, but my personal opinion is that it's yes and no. Like, it is, I think it could be fair, but unfortunately, the politics involved make it not fair, I think. That's my personal opinion. I don't know how you feel about it, but the problem is that, you have democracy, and then once you establish this system, you have each of these fiefdoms, especially in the United States, where you have these different states, and each state gets to decide on a bunch of different things about the state. Take, for example, the way we decide districts. So if the state is run, for example, Ohio is largely run by Republicans, and so the Republicans have an incentive to partition the state into groups where the Republicans will be more likely to be voted into Congress. And so you have that issue, that the way that we decide these things. The Electoral College is horribly non-democratic, I feel. But here, I thought it would be interesting to combine. So the question that I had is combine the Electoral College. So take the Electoral College and ask this the question. You have a number of votes for each of these states. So I have all of the data I downloaded from the various websites. You have number of votes and populations for each of the states. And interestingly, when I downloaded that, I was able to get the density per square mile. Just that's has nothing to do with democracy or choices, but it was just an interesting little tidbit that you have. For example, Wyoming has 6 people per square mile. Alaska, of course, has the lowest density, 1 person per square mile in Alaska. So as you look through, it's like, well, where's the most dense? The most dense, by the way, is D.C. Washington, D.C. is the most dense of our. It's not a state, but it gets electoral votes. Here, let me just go down here. Where is it? There is it. District of Columbia. It's 11,262 people per square mile. Of course, this is going to be the case for any big city. It's going to be very dense like this. But District of Columbia, it's special. It's got a star next to it because it's not really a state. It's not a state. But they get to vote on the president. So technically, those people in the District of Columbia are not represented in Congress, nor are they represented in the Senate. So even though there are more people there, wait, are there more? Yeah, there are more people there than many states. You can look at these smaller states. Let's see, there's 3 million people apparently in the District of Columbia. And yeah, that's 6 times Wyoming, the smallest state. So anyway, I have an issue with that. That's problematic, I feel. I know that many people probably wouldn't, at least if the people that are in the Republican Party probably would be happy that they don't get as much of a say, because typically 80% of the DC residents vote Democratic. But anyway, getting on, yeah, anytime you have that sort of thing where a particular party can manipulate the outcome just by the rules, that I feel is undemocratic. But moving on, you can see the populations. There's an interesting little phenomenon that I found where is it? Where is it? Just a minute, maybe I missed it. Oh, there it is. Yeah, there it is. So Nebraska and Idaho. At first I was confused by this. Look, Nebraska has 5 electoral college votes, and they have 1.988 million, 1,988,000 people. Idaho has 4 electoral college votes, but has more people. I thought that wasn't supposed to happen, especially when we're using Hill Huntington. But I realized these population figures are not from the census. These are estimated population figures that I downloaded from 2000 this year. So these population data is not from the last census. So that little anomaly shouldn't really have happened. I probably should have gone and grabbed the 2020 numbers, but whatever. I was doing the best I could. Anyway, the question I had though was if we did the Shapley-Shubik Power Index or the Banzhaf Power Index for these 51 voting members of the Electoral College, what would we find? How much power does California have? They have the most Electoral College votes. How much power does Wyoming have? They have the fewest, and along with all the other small states. So how much power do each of these have? Well, in order to do that, we would have to actually write down permutations. How many permutations? So I guess the question is, how much work is this? If I were to do the Shapley-Shubik Power Index or Banzhaf Power Index, how much work is it with 51 voting members? So let's go ahead and figure that out. So 51 is the number of voters. If you want to think of each of the states as a voter, so Banzhaf, and then Shapley-Shubik. I'll show you what I'm writing in just a minute. Shubik. So let's get those numbers down first, and then we'll see if it's even feasible to figure out this. So Banzhaf, do you remember how much work one has to do? What's the formula for Banzhaf for how much we need to do coalitions, right? Subsets. So how many subsets, how many coalitions do I have to look at for Banzhaf? Remember how to do that? Yeah. Okay. That one is Shapley-Shubik. So that's the rearrangement. So Shapley-Shubik was, it is 51 factorial, because we're asking Shapley-Shubik. The philosophy was, let's permute all of the voters and see who is the pivotal, who cast the deciding vote. So that's Shapley-Shubik. Banzhaf, on the other hand, that was the coalition's subsets. Do you remember what calculation that was? What was that? Yeah, so the fifth, so the -1 is so small compared to 2 to the 51st that it's eclipsed by it doesn't even matter in this case. So let's go ahead and compute these two numbers. I'm curious. Actually, I've already done it. I deleted that from my spreadsheet because I was discouraged when I got that. Let's do 2 to the 51st. I'll put the -1 there just for fun, but so you don't even see the -1. You know what this means. I like to tell my statistics students that if they see an E there, what that means is it's extreme. This is an extreme number, so it's extremely big. So that's because the statistics students, they just care about, the size of their p-value. But anyway, you know what that means. So it's 2 times 10 to the 15th. That's a huge number. There's no way. I can't write down, certainly not by hand, but fortunately we have computers. Let's do the other one, Shapley-Shubik. This is 51 factorial. It's fact 51. Let's see. Oh, equals. Equals fact 51. And oh, it's even worse. So 1.55 times 10 to the 66th. Wait, what is Avogadro's number? It's pretty close to that, isn't it? It's a big number like that. It's lost to the sands of time, at least for me. But anyway, huge numbers, so big, or Planck's constant is huge like that, isn't it? But whatever. So these are so big, it seems discouraging. How could we do this? Well, certainly there must be a way, to group these things together. And in fact, there is. If we divide out by the number of states that are in each category, because we have a whole bunch of states that are in each of these. Let's go up to the top here. Let's see, how many do we have here? 3. I actually did, you could do a count if. I don't want to scroll over because I have my answers and I don't want to give them away too soon. As you can guess, I do have the calculation. But how many are there? There's 7 or is it 6? I think it's 6. Yeah, 6 states. Oh, if you include District of Columbia, it's 7. Because District of Columbia, I have sorted by population, not by number of votes. So you have 7 different groups, 7 people. Oh yeah, and we don't even give Puerto Rico a say, although they have a small population, but their population is bigger than Wyoming. But anyway, getting back to this, so you have 7 groups that have 3 votes, and then I think there's also 7 with 4 votes. Let's see, 1, 2, 3, 4, 5, 6, and then the 7th, because this is a little out of order. So 7 with 4 votes, and then 5 votes. So we could maybe group things together. That'll reduce the amount of work that we do. In fact, that's the way to go with this. Even that, it's overwhelming though. You end up with something like 10 to the 10 to the 10th. So it's still a huge number of groupings that we have to do. However, you could program a computer to do this. I was going to start doing that, and then I realized someone must have done this already. I did find someone who had done it, thankfully, and oddly enough, it was at my alma mater, at least for my PhD, Temple University. Someone had put together, they had written a paper about this and had put together a nice online calculator that I was able to use to compute the Shapley-Shubik power index and the Banzhaf power index for this voting system. So you might be curious, what are the answers? Okay, so let's see if I can make this a little bit better. We don't care about the density of people. I just put that there because I thought it was curious that that data was available. So let me slide this over so that we can see the important stuff. So we don't care about that. Okay, so what do I have here? Up here in the next 2 columns, I have the Banzhaf power index as a percentage, or it's not really, it's written as a decimal, but you know what I mean. It's a proportion. If you add these up, I get 100% or 1. So you can see here that everyone who has 3 votes has 0.00546 as a proportion of the total power. That's how often they were critical. So you got to remember my terminology here. At the bottom of California, 11%. 11% of the time. Of course, nowadays, California generally votes Democratic, and so it's not, but still, critical 11% of the time. So that's a huge difference, isn't it? California is bigger than Wyoming by a factor of about 70. 70 times bigger than Wyoming. And so what's the deal there? They have 11%. Here it's about 0.5%. So in terms of, they have about 20 times the power, even though they're 70 times as big as Wyoming. What I did here, though, was I said, okay, what really matters is individual voters. Since we're dealing with populations, each voter, if you take this power and divide it up among all the voters, which I'm not sure that that's really the best way to do this, but it's one way to think about how much power do I have in relation to, in how much of a say do I have in terms of the presidential election compared with someone from Wyoming. Well, someone from Wyoming has this much power. I know that's a really small number, but you can compare small numbers and say that this person has more power than this person. Move to Wyoming, and suddenly, well, you're going to have no say if you're technically, because Wyoming is going to vote Republican generally, but you have more say than someone in Vermont, let's say. So if we go through here, you can kind of see how things shake out. That the smaller states seem to have more power. If you live in a smaller state, you have more of a say. Let's see, where is Ohio? We're getting close. Ohio, I'm curious. I didn't look this. I was more interested in the top and the bottom. Oh, here we are. Okay, 2.63, which is roughly 1/4 of Wyoming. So 2.63 compared to Wyoming was 9 point something. Maybe that's a little bit less than 3.5. 3.5 times 1 over 3.5. Anyway, let's go down to California. So here's the problem I have. Oh, wow, California, they have more power than we do in Ohio individually. Huh. Well, anyway, that's my beef is that you look at the differences, and if we were, I could have done minimum, the minimum and the maximum. The maximum is Wyoming. Minimum looks like it's down here. This one, Florida. Hmm. You wouldn't know it, thinking of Florida being a sort of a quasi swing state. We used to be a swing state. You know, the presidents used to care about what I voted. Now they don't. I actually had one person come and bug me and come to my door. And I was like, why? Why are you here? Like, down ballot, down ballot. Okay, whatever. So, but anyway, there's bands half. Interestingly enough, we can do the same thing for Shapley-Shubik. So here's Shapley-Shubik power index. Same deal, very similar numbers. So, you know, you have almost the same number. Wait a minute, let me extend this over. Let's pull this over, pull this here. Oh, wow, it's exactly point. I thought that was rounded. It's not. Okay, so it's almost the same number. Interesting. Uh, wow, I didn't notice that when I did this earlier. They're almost exactly the same. They're very similar. I think they're different down at the bottom. No, they're close. Okay, so fascinating. So then this is the dividing by the population just to see how much of a share of the power you have if you live in these states. So there's one thing that I don't like. By the way, historically, I was as I was looking this up, the way that we decide who gets the votes in the electoral college has changed. Originally, it was left up to the states, and different states did it different ways. Some of them did a proportional sort of like Maine and Nebraska now have sort of a proportional. It's by district. Each electoral or congressional district gets to decide for themselves, and then the state has sort of the popular vote for the two senators. So I think that's at least a little bit more fair than what we do now. But we didn't have this winner take all system until the mid 1800s. Apparently, if we had a winner take all system in 1796, Adams would not have been our president. It would have been Jefferson in 1796. And perhaps then, um, who is it? Hamilton wouldn't have been shot, you know, because I don't know. It was all because of the 1800 election. But anyway, back to this. So the way that we have chosen who gets, you know, the electoral votes from each state has changed over time. And so now I think it's one of the most unfair ways, but no one has an incentive to go the way of Nebraska and Maine because it dilutes the amount of power you have. Because if you split up your electoral votes, then you have less of a say. I mean, it actually does work out that way, despite the fact that the small states have the most say. It seems it doesn't translate when you divide up your electoral votes. Um, so that I feel like is a problem. If we could get away from that, maybe just have proportional representation in the electoral college. Then also the Senate is much worse than it used to be. The Senate, if you think about number of senators, just to go back here, and then I'll be done complaining. You can tell I'm super cynical about politics. But at Wyoming, each senator, two senators, each senator represents technically about a little less than 300,000 people. And then you go down to like the bigger states, each senator here, two senators, each senator has to represent almost 20 million people, 19 million people. So the Senate, back in the original Senate, the difference between the biggest and small states was less than it is now. Now the difference is huge. And I don't know, it bothers me when you have these inequities in our system. All right, well, I've gotten that out of my system. Thank you. But if you have any, like, if you've got comments or ideas, like, well, what's this? I could go compute it, or you know, why is it? You know, I'm curious. Like, I was curious. Mike, the reason I did all this is I was curious about if you take the electoral college, which we were looking at because it's apportionment issue, and you combine it with this weighted voting, can we figure out how much each state has in terms of say or power, and then I can translate that into number of people. Maybe this is inappropriate, I don't know. But are there questions like that that have popped into your mind either today or in the past where you're like, you know, I wonder, what would this look like? I mean, I could dig out the numbers for you, but I mean, I'm always curious if you're, this is something I've been curious about, so I was happy to be able to do this over the past couple days. Um, but maybe you have your own curious things. All right, maybe I should have made that an assignment. Tell me something interesting that I can look up. This is, I guess I like being able to, even though like I'm very cynical. I don't know if you caught that. Super cynical about politics, but I'm super interested about being able to figure out things like this. I don't know. So, yeah. Okay, well, anyway, so let's talk about next week. We have a test next week, and on that test, we're going to have some voting systems. And so we have the voting. Wait, we did the voting already. That was on test one. It's apportionment, and I thought I could throw on a couple of these basic weighted voting, not the hard ones, a couple basic ones. I'll try to have something together in terms of what is it called? Like a practice test certainly by next Tuesday, but I'm hoping to get it together before this weekend because I don't have a lot to do for tomorrow because I've got all my tests already. So today I'll work on that. And then next week we'll just talk about that and try to wrap things up. So for you, what you're going to be doing for me, just to remind you, we have the Excel spreadsheet thing. I can help you with it. We have time now if you have questions. Some of you are done with it. Some of you are like not even started, maybe. So we can get help with that. So that's coming up, I guess, after Thanksgiving. The career paper is next week. Is that what I said it was due? Yeah, next week. So that's sooner. So if you have questions about that, we can deal with those. And then the career presentation you're going to do for me after Thanksgiving. So it's not going to be a big deal. Once you get your paper presentation, you could probably just do off the cuff. So questions about any of those things that we can deal with? Yeah, what do you think, Audrey?
How long is the presentation supposed to be? Like, you said we're supposed to make slides. How many slides?
I don't know, whatever you think is appropriate. But in terms of length, I'd say 5 minutes is fine. That's the way it's in the past. It's been like 5 to 10 minutes max. No one's gone more than 10 minutes. And so remember, we've got 5 people on each day. So we want to leave room for transition and all that. So if you do 5 minutes, that's going to be a total of maybe 45 minutes once we deal with all the transitions if everyone does 5. So yeah, it doesn't have to be a big deal. And then slides, you can get creative. Some people in the past, I think the minimum has been like 2 slides. Yeah, the fewer words. By the way, when you do presentations, you probably know this, but if you don't, the fewer words, the better on a slide. Like this, too many words, too many numbers. You can't digest this. So PowerPoint, I'm not always good with this in terms of when I do PowerPoint, but I think, I forget what the standard is. If it's 7 words, I don't know. It's like a really small number, shockingly small in terms of how many words you should have on each slide. Oh, maybe it's 7 per bullet point.
I think it's 7 by 7. So 7 bullet points would be
7 bullet points?
max.
I was thinking 3.
I think it's 7 by 7.
Wow, that's so many. I can't even imagine. Yeah, I always hate it when I go, like, it's always funny, if I'm in a faculty meeting and someone gets up there and does a presentation and has like this PowerPoint that has paragraphs, like 2 or 3 paragraphs, like I can't even read those for one. So yeah, 7 by 7. I was thinking 7, 3, but you do what you do whatever. And if you have big paragraphs, I'm not going to mark it wrong. But yeah, you probably could cram it onto 2, but you might want to spread it out. I think there's certain, you could even do 1 slide for each of the items that I'm asking you to present, but you don't have to. Get creative, and I'm looking forward to seeing all of those things fold up and the airplane shooting off like you did for the first one. So anything else? Other questions about any of the assignments that we need to deal with? All right, well, if you do, I know that some of you are done with the Excel spreadsheet. Some of you haven't, maybe, I don't want to say, I'm guessing. Some of you may not have started the Excel spreadsheet. If you might want to start it before Thanksgiving so that you can come and bug me if you're like, I don't know how to do such and such, and I'll do my best. I can tell you what I did, but I'm kind of curious to see what you do. So if you're doing your Excel spreadsheet and you're like, I can't figure out this one aspect, like how do you round down? How do you deal with searching along, whatever it is? I can help you with that, but only if you do it before Thanksgiving. So you might want to try it out this weekend if you haven't started yet. All right, so nothing else? No other complaints? Look, I have no complaints other than the complaint that I don't have enough stuff to show you more today. But I don't know, I was excited about this, so I wanted to make sure I shared it with you. All right, so if you have nothing else, we can take a little more time to have breakfast. So I am. I see there's some piles. I'll come get it, I guess. I don't know. I need to return this stuff. I'm not as inspired for you as I should be. So maybe I should have a goal of getting it all back to you on Tuesday. But certainly tests I always have return day after. So I'll give you credit. Put a check mark in the book. Oh, this is you. Okay, this.
Did we just try to that would be and then okay, I think it's on.
Yeah.
I don't know if my name
You know, in the video, you said, oh yeah, make piles. So I was like,
Yeah.
okay. So I turned it in.
So yours is going to this pile, but I'll sort it out when I get there. All right, thanks for coming. This rainy day. Oh, I'll stop the recording so that if you have to come talk, here, let me do this. Stop it.